Okay, in this video I want to introduce the least common denominator, which I'll refer to as the LCD. This is really important if we want to start talking about fractions, and especially fractions with expressions. Okay, so rational expressions. How can we add them? We have to dive deep into the LCD. So let's get into it. So the first example, I'm going to go all the way back to grade school and talk about this, just because I think it will give us a little better footing of when they become expressions. So 1/2 plus 1/3. Okay, well, how do you do this? We could argue the various different ways that you can do this, but I think we would agree that the denominator definitely needs to be a 6, right? We would agree on that. Now, some people do the cross multiplication, and some people just change the value of it, but I think we would agree that it has to be 6 for the denominator. This 6 is the LCD. So the LCD for this problem is 6. Okay, that's the lowest number that the denominator, that both of these could be for this to be put together. Now, of course, we know that it's 2 plus 3 for this problem. So the answer is 5, 6, right? You can do your cross multiplication, or you can actually change the 2 by multiplying it by 3 and changing the 1 by multiplying it by 3, and the same for multiplying by 2, both top and bottom. However, the denominator, I believe we'll agree on, has to be 6. Okay, now for something like 1/6 plus 1/12, okay, well, what's the lowest common denominator? I would say it's 12, okay? Now, why is it 12? Because I can make a 6 into a 12, and I don't want to go any further with making this changing the 12. There's no need to change it. Of course, you could multiply them, but why? It's going to be best if we can go as small as possible. So I don't think there's any reason to, turn these into 72 or anything. So anyway, I would argue that the denominator should be 12. So the LCD is 12, right? So I can actually turn a 6 into a 12. So that would be 2 12s plus 1 12, which is 3 12s. And then after that, we need to reduce. Okay, so for this, I actually need to reduce to 1/4. Okay, but the LCD needs to be 12. All right, let's look at the problem like this: 2/5 plus 3/7. Well, what's the LCD? Well, 5 and 7, they don't really have anything to do with each other. So I think probably the best thing to do is just multiply them. So I think the LCD for this problem is probably going to be 35, since they have no real shared value. Okay, so I think it's 35. Well, what would I need to multiply the 5 by to make the 5 35? And that's 7, so I could say that this is 14. And what do I need to multiply the 7 by to get 35? And that's 5, so it'd be plus 15. And you just add you just add these two together. Okay, so what would that? 29 35ths, and it doesn't look like we can reduce. So that's how you can do those simple problems. Well, what if they're more advanced? Let's talk about if they were variables. So if you had 1 over x plus 1 over y, well, what would the LCD be? So the LCD, since x and y have nothing to do with each other, the LCD is going to be x times y. Very similar to the 5 times 7. Okay, so I think the LCD has to be x, y. What did I multiply the x by to make it xy? I need to multiply it by y. So I'd have y plus x. And that's all the reduction I can do for that one. What about this one? 1 over x plus 1 over 2x. What would the LCD be for this? Okay, well, this has an x. This also has an x, but this has a 2, and this doesn't have a 2. So the LCD for this one is going to be 2x. Okay, so that's 2x. Okay, well, what do I need to multiply this x by for it to be 2x? I need to multiply it by 2. So that 1 is going to become 2. And what did I need to multiply this denominator to make it 2x? Nothing. So the 1 doesn't need to change either. So that would be 3 over 2x, and that won't simplify. Okay. Well, what about this last one here? 1 over x plus 1 over x squared. Well, what would the LCD be? I think it's x squared. I can multiply this x by another x to make it x squared. And so there's really no reason to change this. So I think the LCD has to be x squared. What do I need to multiply this x by to get x squared? An x. So the 1 will become an x because 1 times x is x. And what do I need to change about this x squared? Nothing. So the 1 doesn't need to change either. Okay? So those are just some easy problems, hopefully to give you kind of a head start of how we can do the beginning of our lesson. So 2 over 12x to the 7th, 3 over 4x squared. I don't actually want to add these, so these are just a comma. I want to just talk about what would the LCD be. So let's not add them. Let's just talk about what would the LCD be. So between 12 and 4, what would the LCD be? I would argue that it'd have to be 12. I can turn a 4 into a 12, but I'm not going to turn a 12 into a 4, so that would have to be 12. I have x to the 7th and x squared. So what would the LCD be for the variable? X to the 7th. Okay? This feels very similar to the greatest common factor, but in some ways it's the exact opposite. So to make the common denominator, you have to take something that has all the pieces and no less. Okay, so factoring, you take out the smallest piece. With the denominators, you have to take out the biggest piece. Okay. Now, what about this 9x plus 27, 2x plus 2? Well, I can actually change this so it looks a little different. That would be x plus 3. So 9 times x plus 3. If I factor out this 2, that's x plus 2 right there. I can make that a little neater. X plus 2. Okay, so what pieces do I have to play with? Well, for the LCD, all of the pieces have to be represented. So the 9 has to be represented, the 2 has to be represented, the x plus 3, and the x plus 2. So that would be the LCD. And if you want, you can turn the 9 times 2 into 18. And some people like to write these in ascending order. But that would be the LCD for this, okay? So that's the LCD. Again, right now I'm just talking about what is the lowest common denominator. I'm not talking about how we would add them yet. Let's continue talking about the LCD. So for this, I have x squared minus z squared, and I have x squared minus 2xz plus z squared. So I want to find the LCD between these. I think the best thing to do is start factoring. This is a difference of squares, so I can use that difference of squares formula that we derived, x minus z. So I know what I'm looking at. What about this one? I have x squared minus 2xz plus z squared. This looks like a perfect square. Is it? Yeah, I think it is. So we have x minus z squared. Okay. You can check your cross terms. 2 times x is 2x times negative z would be negative 2xz. That's exactly what we want. All right. So this has 2x minus z's. This only has 1, and this has an x plus z. So for the grand total LCD, I think we need 2 of them. I have to include all the pieces. So that would be there. And then we have 1x plus z. Again, I don't have to do 3 of them. I just have to include all of the pieces. And since this has 2, I have to pick the biggest one. Since this already has 1, that's covered. But with the plus sign, I need to use that. Okay, let's talk about the LCD for this problem. X squared minus 1, that looks like a difference of squares. 5 minus 5x, looks like I could factor out a 5 and then just an x here. All right, so I'm going to break this up and see what pieces we're looking at. We have x. Again, this is a difference of squares, so x plus 1, x minus 1. Here, it looks like I can factor out a 5, which would leave 1 minus x. And then here I have an x. Okay, So the LCD has to include these pieces, the 5, this one, and the x. So I need to do that. So let's do it. We can go 5x, x plus 1, x minus 1, 1 minus x. Okay, that's one way to write it. Some of you might notice that x minus 1 and 1 minus x are the same thing but opposites. And so something that is starting to creep in our algebra lessons is that you can actually just manipulate the sign. And if you take a negative sign out of this, it's the same thing. So this would be equivalent as negative 5x minus 1, which is the same thing. So this would be equivalent to saying negative 5x, x plus 1, x minus 1. Okay. But they're equivalent statements, so you're fine. However, it is useful to see that you can manipulate that negative sign when we do start adding. Right now, it doesn't really matter because we're just identifying it. But my motivation to learning to be able to do that is when I'm adding, it will reduce a lot of the steps I need to do. Okay, so I hope that makes sense. And again, that's a subtle but important point, so please let me know if that's not making sense. Let's talk about actually adding these things. So first, I argue, let's find that LCD. If you find the LCD first, the amount of work you have to do is going to really go down. This is a problem that always gets algebra students trouble, so I want to go over it in detail. With this x plus x over 6, this number might change, plus 6 over x. What is the LCD? One thing we should notice is that there's actually like a silent 1 over that x. So this is kind of like a whole x, but there's a 1 over it. So what is the LCD? We have 1, 6, and x. Well, those are all independent, so we know that the LCD just has to be 6x. Okay. Well, what do I need to multiply this 1 to become 6x? That's going to become, for that to become 6x, I have to multiply top and bottom by 6x. So this would be 6x squared. Okay. So the x times x makes the x squared and then the 6. What do I need to multiply the 6 by to become 6x? I'm going to have to multiply it by x, right? So 6x, that would give me x squared right there. All right, what do I need to multiply this x by to get 6x? I need to multiply it by 6, so that's going to become 36. All right. Now we can simplify a little further. Right, equal sign there. 6, now they're all over the same denominator, so now we can add them. 6x squared plus x squared would be 7x squared, and then plus 36. Okay, that looks like the farthest we can go with that problem, but I hope that helps. Of if you find the LCD, you can make all of the denominators that LCD, and then you can go from there. You can add the numerators. And the last step would be to reduce if possible, but for this one, it isn't possible. Okay. Let's look at this one. This is also the type of problem that gives algebra students a lot of trouble, and it's not that bad if you know what to do, but it is about knowing what to do. So I have 5x quantity, and then this is like the opposite of squaring. So this is negative 2 plus x to the negative 2. Well, from previous videos we learned, or we talked about, that negative 2 or a negative exponent means those things are going to come in the denominator. So I can rewrite this problem as 5x squared. Now it's positive because I've brought it down to the denominator. And that's the same with this term, would become x squared. Okay. Now, I can simplify this further using my exponent rules. So that would be 5 squared, which is 25, x squared plus 1 over x squared. Okay, now we're finally ready. What is that LCD? Well, we have 25x squared, x squared, so the LCD is 25x squared. Okay. Now from there, what does this denominator need to become 25x squared? It doesn't need anything. It has everything. So we don't need to change this one. What does this denominator need to be to become 25x squared? It needs the 25. So I'll rewrite this one first, and then I'll multiply 25 to make 25x squared. 1 times 25 is 25, and there it is. And now they're all the same denominator, so I can simply add 1 plus 25 is 26, 25x to the seconds. Okay, so that would be the final answer there. And you reduce if you can, but 26 over 25 is irreducible. So that's how you can do it. So yeah, sometimes you have to do a couple steps before you can actually even get to the point where you find the LCD. But if you find the LCD, it can really save you some, it can make the problem a lot easier for yourself if you do that. Let's look at this one. 1 over x squared plus 4 over x squared plus x. So for this one, there's not much to be done with the x squared. It does look like I could factor out an x out of this one. So let's go ahead and do that. 1 over x squared plus 4 over x plus 1. Okay. Now what is the LCD? I have x squared, I have an x, and then I have x plus 1. Well, the x and the x squared, so the x is already within the x squared, so I can just write x squared there. I can just take this one, but that doesn't have x plus 1, so I need the x plus 1. Now everything is encapsulated in this LCD. Okay, so what is the x squared denominator? What is that missing to become the LCD? It's missing the x plus 1. Okay, so I had to multiply by x plus 1, so 1 times x plus 1 is x plus 1. Okay, what do I need to multiply by this denominator for it to become the LCD? I need to multiply it by another x, so it becomes x squared. So I need to multiply that 4 by x as well. Okay, now there's a little bit of simplification I can do and reducing, but that's pretty much it. Now let's see what happens. So I have everything over the same denominator, so that's great. Let's see what happens. I have x plus 1 plus 4x, and it looks like I could just add these together. So 5x plus 1, x squared, x plus 1. And I think that looks pretty good. I'm going to leave it like this. I don't think we need to expand this at all. I think this is looking good. So yeah, hopefully that helps you. I've seen how we're getting those LCDs, but just in case, let's do another example. So I have 4y over y minus 8 plus 7 over 8 minus y. And this is really where that negative sign trick is going to come up in a big way. These are almost the exact same thing, but not quite. So 8 minus y is equivalent as saying the opposite, the negative sign, y minus 8. So these are equivalent, and from there you can see the only difference is a negative sign. So by doing this, I think it will save you a lot of work and a lot of headache if you can see that that can be done. So that would make the LCD, and I have to include this like -1 here, so negative y minus 8. So I can finish the problem using this. If you use the other LCD, it can be a little bit tricky with the reducing at the end, and that's where the work will kind of show up. So let's see what happens. What did I need to multiply y minus 8 to get negative y minus 8? I just need to put on a minus sign. So that's what I'm going to do. So I have minus y minus 8, and so that's going to make negative 4y. Now, I claim that this is already negative y minus 8, so the 7 is ready to go. Okay. Now, they're over the same denominator, so I can put them together. So I have negative 4y plus 7, negative y minus 8. Now, if we want, we can now multiply everything by a negative 1 to get this out of the denominator. So if I do that, I can simply go y minus 8, 7. It should be 4y minus 7, okay? And that would be the final answer, okay? But sometimes those can get a little bit tricky. So I hope that helps. Please let me know if you have any further questions, but that should give you a head start on how you can start adding these expressions.